Hello, how there? In this class, we'll be looking at sum of geometric progression. How does sum of geometric progression come into being? Don't forget what is meant by geometric progression. Geometric progression happens to be the set of arrangement of terms that are well defined, in which they are differ by a common ratio. Every successive terms differ by a common ratio compared to the one that is before it. Now, when we now try to add this set of terms together, we get what we call our sum of nth term of geometric progression. We have the formula that we make use of when we are dealing with questions that involve sum of geometric progression. But here, let's look at how those formula are derived. Now, if you have sum of nth term of GP will be, don't forget the first term is usually A plus AR, that is the second term, plus AR raised to power of 2, this is the third term. It goes on like that, plus AR raised to power over n minus 2 plus AR raised to power n minus 1. We have this set of arrangement, that is, we try to add all those terms together. Let's call this equation 1. Now, I've called that equation 1. Now, we can now look at this set of information we have here. I can now say that multiply through by common ratio R. That is, everything in this set of addition of terms that we have, multiply everything by R. We now have R multiplied by sum of terms here is equal to A multiplied by R. This is AR plus AR squared plus AR raised to the power of 3 goes on like that to AR raised to the power of n. That is how it's going to go like that. It's going to go to AR raised to the power of n. Now, after we've been able to arrive at this, let's call this equation 2. Now, we are going to be able to derive two equations from this first equation and the second equation we have here. Now, the first one we're going to derive is, let's subtract equation 1 from 2. Don't forget, this is equation 1. When we try to subtract equation 1 from 2, we are going to have minus n. This one will give us this one minus this. You can see this is the like terms. AR minus AR will cancel each other out there. AR squared minus AR squared will cancel each other there. Likewise, they are going to have a value that will be AR raised to the power of 3 here. It's going to be in the middle here. Then all this one too will be able to cancel, leaving behind AR raised to the power of n and A. So we are going to have AR raised to the power of n minus A. Now, in this regard, now we can now say that what is the common term here, which is what? Sum of nth term into bracket of R minus 1. If you try to open up this bracket, you will get this particular information back. Now, it will be equal to, what is the common term here? The common term here is A into bracket R raised to the power of n minus 1. Now, we can now say, we want to find the sum of n term, right? So we can now say that divide both sides by R minus 1. So we have sum of n term into bracket R minus 1 over R minus 1 is equal to A into bracket R raised to the power n minus 1 over R minus 1, which this one will give us sum of n term is equal to, because this will cut each other out, is equal to A into bracket R raised to the power n minus 1 all over R minus 1. This equation is make use of, and is best to make use when we have the value of r greater than 1. In other words, when you are trying to find the value of sum of n term, you must make sure that you know the value of a common ratio. When you know the value of the common ratio, you look at the value that you have there, and it's greater than 1, then you know that you are going to make use of this information to find the sum of the n term of the geometric progression. Now, we have been able to find this value by saying that we subtract equation 1 from equation 2 that we have here. Now, let's look at another equation by subtracting equation 2 from 1 and see what that equation is going to give to us. Now, I'm going to subtract equation 2 from 1 now. So, which I'm going to have this one value here minus r is n will be equal to a minus ar raised power of n. Now, if you look at this one, what is the common term there is a sum of terms, which is going to be equal to 1 minus r. When you divide this information here by this, you're going to get this information here. What is the common term here as well? That is a into divided by this, that's 1 minus ar raised power of n divided by this, that's minus r raised power of n. Now, having got this now, you can now say that divide both sides by 1 minus r. Divide both sides by 1 minus r. So we have sum of terms into bracket 1 minus r all over 1 minus r is equal to a into bracket 1 minus r raised power n over 1 minus r. So we have sum of n term now will be equal to a into bracket 1, because this will call this one out, 1 minus r raised power of n all over 1 minus r. That is how we get this formula. We have been able to get the formula where we have when r is greater than 1. That is the formula that is best suitable to apply for such a particular question to solve when r is greater than 1. Then in this case here, this is very suitable for when r is less than 1. When r is less than 1, you can make use of this formula to solve the sum of the nth terms. Let's now look at some question as regard sum of n terms. As a question, we have a source to find the sum of the 10th term of this geometric progression. Ordinarily, the terms are given to us. The terms are 16. Make use of this now. 16, 8, and 4. Those are the terms given to us. And we have this a is equal to 16. That is, our first term is equal to 16. Now, I haven't got our first term to be equal to 16. You know that when you want to find the sum of n term, you need to find the value of the common ratio. Now, because the common ratio will determine the nature of the formula that you can make use of to get a sum of n terms. Now, for the common ratio now, common ratio will either be 8 over 16 or 4 over 8, which the two of them will give us 1 over 2. So we've been able to get the value of our common ratio to be equal to 1 over 2. Now, I haven't got this like this. So 1 over 2 is less than 1. That is 0.5. It is less than 1. R is less than 1. So in that regard, we make use of this formula, which is sum of n term is 1 minus r raised power n, a into bracket 1 minus r raised power n over 1 minus r. That is the formula we're going to make use of. Because r is less than 1, we make use of this formula here. Now for the sum of a 10th term now, the sum of 10th term will now be equal to, what's the value of r here? 16 into 1 minus r raised power of n. What is our r? 1 over 2 raised power of 10 minus 1 minus 1 over 2. 1 minus 1 over 2. We have sum of the 10th term now will be equal to 16 into bracket 1 minus 1 raised power 10 is 1 2 raised power 10 is 1024. 1024 all over 1 minus 1 over 2. 1 minus 1 over 2. Now, when you look at it, we are going to find the LCM of this particular value here. So we can now say that sum of the 10 term is equal to 16 into bracket 1 minus 1 over 1024. I put this here. I have 1024 as the LCM. Don't forget, it's still all over 1 minus 1 over 2. 1 minus 1 over 2. I think I should also find the LCM there as well. Now, there I'm going to have 1. This one is over 1. 1024 over 1 minus 1 over 1024. This one will be, this is, what is the further LCM here? 2. This one is going to be 2 minus 1. So the sum of the 10 term will be equal to 16 into bracket of 1023 over 1024 all over, or divided by 1 over 2. 2 minus 1 is 1 over 2. That is how what we get here. The value we get at this denominator here is this one here. 2 minus 1, 1 over 2. The value we get here is the one that is here. 1024 minus 1, 1023 over 1024. I think it is clear in that way. Good. Now we move ahead to solve it this way. Sum of the 10 term will now become 16 multiplied by 16 into bracket of 1023 all over 1024 times 2 over 1. You know that when you change this one to multiplication, the value at the denominator comes to numerator, and the numerator goes down to denominator side. So we have the sum of 10 term now to be equal to 16 times 2 is 32 into bracket 1023 over 1024. So when you look at it very well, divide 1024 by 32 is going to be in 32. So sum of the 10 term will now be equal to 1023 all over 32. So that is the value for the sum of the 10th term of this particular expression that we have here. 1023 over 32. More questions are still coming that will be useful for you. This might be a little bit difficult to solve. We are going to solve it here. The question we have here is on the sum of geometric progression terms that have been given to us. We are asked to find the geometric progression terms. Now, how do we get this kind of question? Now, we've been given the value of the first two, sum of the first two terms, and we're also given the value of the first four terms. Now, we are now going to make use of that information to get the value of our first term, second term, third term, and the geometric progression terms in that order like that. So let's look at how we are going to solve this question now. The sum of the two terms, first two terms, that is sum of first two terms, which is going to be equal to sum of the first two terms, that is s, 2, that's what going to be equal to. Don't forget that it has been given to us, or it has been stated there that the value of the common ratio is greater than 0. In other words, it is greater than 1. That is what the mean there. So that will be a into bracket r raised power n minus 1 all over r minus 1, which has been given to us to be equal to minus 60. This is the information given to us. Now, the sum of the four terms as well. Sum of the four terms, that will be equal to a into bracket r raised power over n minus 1 all over r minus 1 is equal to minus 63.75. Now, in this case here, you know that I have the sum of the second term here. I think this one should be changed to 2. This one should be changed to 4. Now, I won't call this value out like this now. I can now say that Let me now divide these two information by one another. I can now say that divide equation or divide like okay equation 2 by 1. So I call this equation 2, I call this equation 1. So I can now say that this dividing them, you can now have a into bracket r is power 4 minus 1 all over r minus 1 divided by this one now, a into bracket r is power 2 minus 1 over r minus 1 will be equal to this value here, minus 63.75 all over minus 60. Now, I'll change this value here to multiplication. I'll have a into bracket r is power 4 minus 1 over r minus 1 times r minus 1 all over a into bracket r is power 2 minus 1 is equal to 63.75 over minus 60. So don't forget that the negative value will cut each other out. This one too will cut each other out. This one is positive, yeah? Sorry, it's positive. So we are having what is left behind for us now is this a, also we call this a. We are having behind r is power 4 minus 1 over r is power 2 minus 1. We have r is power 4 minus 1 over r is power 2 minus 1 is equal to 63.75 over 60. Now 63.75 over 60, I think we should be able to get the value of that. Now, then let us get that now for now. Now, from here now, I can now say that this value here is r is power 4 minus 1. I can now find its perfect square by just saying that it's going to be r is power 2 plus 1, r is power 2 minus 1, all over r is power 2 minus 1 is equal to 63.75 over 60. So if you look at it very well, you call this one out. Now, somebody will be asking me, how do I get r is power 2 plus 1? If you expand this bracket, the between r is power 2 plus 1 and r is power 2 minus 1, if you open up the bracket back, you'll get this r is power 4 minus 1. That is a perfect square of this particular value we have here. Now, now that it has been saying that that one has been cut out, then we can now say that the value we are having behind is r is power of 2 plus 1 is equal to 63.75 all over 60. So we cross multiply, we're having 60r squared plus 60 is equal to 63.75. So we have 60r squared will be equal to, you subtract this one from both sides, you have 63.75 minus 60. So we are having 60r squared will be equal to 3.75. 3.75, where r will be equal to, r square will be equal to 3.75 over 60. That is the r square now. 3.75 over 60. We are going to have 0.0625. R square is equal to 0.0625. Where r will now be equal to square root of 0.0625. R will be equal to, when you find the square root of this value here, you are going to get 0.25. You'll get 0.25 when you find the square root of 0.0625. Now, that is the value of r right now. Now, we need to find the value of our first term, right? Now, having gotten the value of our common ratio to be equal to 0.25, we can insert it into any of these two equations, either in equation 1 or 2. So I'm going to make use of equation 1 now. Let r equal to 0.25 in equation 1 now. So I'm having that now. We have known that is going to be a into bracket 0.25 raised power of 2 minus 1 all over 0.25 minus 1 is equal to minus 60. Now 0.25 raised power 2 will give us, this one is now equal to A into bracket 0.0625 minus 1 all over 0.25 minus 1 will give us a minus 0.75. Minus 0.75 is equal to minus 60 over 1 as well. Now, here we can now cross multiply. We can now say A into bracket 0.0625 minus 1. Let's solve that one. 0.06625 minus 1. That one gives us 0.9375. That's minus 0.9375 will be equal to this multiplied by the, this, so it's multiplying by this, which is 1. So it's going to be the same value that there. 0.75 multiplied by minus 60. That is going to give us a positive answer. That one will give us 45. 45. Check your calculator. You can get that. Now, for us to find the value of A, we can now say that A is equal to 45 all over negative value of 0.9375. 45 divided by 0.9375 will give us 0.9375. That will give us 48. So A is equal to minus 48. So having known the value of our common ratio as 0.25, so we can now say that this is the first term. AR will be equal to minus 48 multiplied by 0.25. Minus 48 multiplied by 0.25. That one will give us 12. This is 12. AR raised power of 2. This is minus 12 as well. AR raised power of 2, which is 0.25 raised power of 2. Raised power of 2 multiplied by 48. That minus 48. That one will give us minus 3. AR is equal to 2 is equal to minus 3. So the terms of GP, the GP of that's minus 48, comma, minus 12, comma, minus 3. This is the first term, this is the second term, and this is the third term. We have here, we are asked to find the terms of geometric progression. Now, in this question, we will be given the product of second and fourth term. The question says that it doubled the fifth term. Now, in that approach, we are also told that the sum of the first four terms is 80. Then we are asked to find the geometric progression. Now, for us to approach this kind of a question, let's firstly look at the product of the so-called second and fourth term. Now, in geometric progression, the first term is given to us to be A. The second term, we know it is AR, where the third term is AR squared. When we follow the nth term formula of n is equal to AR raised power of n minus 1. Now, in this case now, what the question gave us is that the product of second and fourth term, this is the second term, AR, multiplied by the fourth term, which is AR raised power of 3. This question says that it's doubled. The meaning of double means to multiply by a particular value. Doubled the fifth term. What is the fifth term now? AR raised power of 4. Following this formula to get the nth term values. Now, when we have it like this, we can now say, in this case now, A times A is A squared, then R times R is R raised power of 4, will be equal to 2AR raised power of 4. That is the simplification of this value we have here. Now, we can now go ahead and look at it. For us to find, we have intention of finding a particular value here. Now, we can now say, okay, divide both sides by AR raised to power 4 because those values are present in each side. Divide both sides by AR raised to power 4. In other words, we are dividing it by all the value of AR raised to power 4 that we have in the right hand side here. So we are going to have A squared R raised to power 4 over AR raised to power 4 is equal to 2 AR raised to power 4 over AR raised to power 4. When we call this, then one of these A goes. Don't forget that this A square means A times A, so it's 2. So one of the A goes out, it remains just a single A. All this one goes as well. Where we have A will now be equal to 2 because it's only 2 that is, there's a value that is remaining at the right hand side here. Now, we have gotten the value of, for the first term, to be equal to 2. We are asked to find the terms of geometric progression, but it doesn't end here. We are still going to solve it further. Now, the question goes further to tell us that the sum of the first 4 terms, sum of first 4 terms is equal to 80. Now, if you want to make use of the first 4 terms as in the formula, it might be a little bit difficult for you because you don't know the value of our R already. So we are going to have problem in the kind of method we are going to use in determining the particular sum. Now, you don't forget that we have different formula for finding the value of the sum of the terms of geometric progression depending on the value of R. When R is greater than 1, we have a formula we make use of, and when R is less than 1, we also have a formula that you can as well make use of. But in this case here now, we are not given the value of R, so it's going to be difficult for us to make use of any particular formula. So in this case, we know that our first term is A, that's the first. Our second term is AR, second. Third term is AR squared. And fourth term is AR raised to power of 3. The question says that the sum of the first 4 terms. So we can now say A plus AR plus AR squared plus AR raised to power of 3 is equal to 80, sorry, is equal to 80. That is a value here. That is what that question tells us, is equal to 80. Now, when it is equal to 80, we have the value of A already. But instead of us to start inserting A into each of those terms, we can now bring, look at the common terms here. The one that is common to every one of them is A. We now have it as A divided by A is 1. AR divided by A plus R. AR squared divided by A, that is what? Plus R squared. AR cubed divided by A, that is what? Plus R raised to the power of 3. Close the bracket is equal to 80. Don't forget the value we get for A here. We can now put it here. 2 into bracket 1 plus R squared plus R raised to the power of 3 is equal to 80. That is what we have right now. Now, from this case now, we can now say, since this is multiplying every terms here, we can divide both sides by that particular value because we have intention of finding the value of R here. So I'll divide both sides by 2. So we are going to have 2 into bracket 1 plus R squared plus R raised to the power of 3 is equal to 80 all over 2 here, all over 2 here as well. So we are having, what is left behind here is 1 plus R squared plus R raised to the power of 3. Because this will cut this one out, 80 over 2 will give us 40. So now here, this is the value that we have right now. 1 plus R squared plus R raised to the power of 3 will give us 40. we are unable to find the value of r yet. So what do we do here is to now factorize that equation. How do we do the factorization? Rearrange this expression here by saying r raised power of 3, that is the highest value or power of r, plus r squared plus r plus 1 equal to 40. Now we bring 40 to this side. We are having r cubed plus r squared plus r plus 1 minus 40 now is equal to 0. We are having r cubed plus r squared plus r minus 39 is equal to 0. Now, when we get to this stage, we now think about how we factorize this expression. But looking at it, this particular information we have here, it has turned into a polynomial because it's having the power of 3. If it is just at 2, if it stopped at 2, the power stopped at 2, we will call it quadratic equation, but this is a polynomial. In that regard, for us to factorize a polynomial, we need to, in the first place, try to find the factors that can be used as a divisor here. Now, I want to make use of r minus 1. If I say r minus 1, r will be equal to, so I say r minus 1 is equal to 0, then r will be equal to my plus 1. If I insert plus 1 into this expression here, in where we have r, if I add everything together and everything result to be equal to 0, then I can use r minus 1 as my factor. So let me try that. We have r is plus 1 now. Now it's 1 raised to power 3 plus 1 raised to power 2 plus 1 minus 39 equal to 0. No, it cannot be equal to 1 plus 1 plus 1. That's going to be 3 minus 39 is not equal to 0. So that one is not a factor. Now I make use of r minus 2 here now. I say r minus 2 equal to 0, where r will be equal to plus 2. Now I put plus 2 here in the position wherever I find r. I have 2 squared plus 2 raised to power 3, plus 2 squared plus 2 minus 39. Can it be equal to 0? 2 raised to power 3 will be equal to, that's 8 plus 4 plus 2 minus 39 is not equal to 0 as well. So that cannot be used as a factor. Is not also the factor of this particular polynomial equation here. Now, I want to make use of r minus 3. Then I can now say that r minus 3 equal to 0, where r will be equal to plus 3. Now, bring it plus 3 into the position we have here. We have 3 raised to power 3 plus 3 raised to power 2 plus 3 minus 39. So let's check it. 3 raised to power 3, this will be equal to 27. 3 raised to power 2, that is what? Plus 9. 3 plus 3 minus 39. Can it be equal to 0? 27 plus 9, that will be equal to 36 plus 3. That's 39 minus 39 give us 0. So the factor of this expression is r minus 3. R minus 3, where r is equal to. So we have been able to get the first value of factors that we are going to find for this factorization of this expression. So we will now go further to factorize this properly. So let's look at how we're going to do the factorization properly. Take a look at it very well. We have this value as the factor that is the divisor now. Is the one that we're going to use as a divisor to divide this expression in order for us to find the remaining factors of r. Now we're having r cubed here, r cubed plus r squared plus r squared plus r minus 39. So we now start with the division. R cubed divided by r. You know, we are going to use the first expression here to divide every value here. R cubed divided by r, that will be r squared. R squared now, you now use it, this value you get here to multiply everything here. R squared times r, that's r cubed r squared times minus 3, that's minus 3r squared. So you subtract it from one another. R cubed minus R cubed, that will give us 0. Plus R squared minus minus, that will be plus R squared plus 3R squared, that's all, plus 4R squared. Plus R, there is no value of R, okay, so that's plus R minus 39. So we now use this again to divide this value here. 4R squared divided by R, that's what? Plus 4R. That will be 4R times R, that's 4R squared. 4R times minus 3, that's minus 12R. So we subtract it from one another again. 4R squared minus 4R squared, that will be 0. Plus R minus minus, that's plus 12R, that's plus 13R minus 39. Plus 13R minus 39. Now, we now have plus 13R now. Since this value we have here as R is still the same value as the R we have here. The same power on it is still the same value. You can see that they are having just one as the power on this RA, and one is also the power on the RA as well. So since they are equal to one another, we can still go ahead to do the division. But if the value of the power of RA is less than the power of this RA, we cannot go ahead with the division. So we cannot do the division here. 13R divided by R, that will be equal to plus 13. So 13 divided by R, 13 multiplied by R, sorry, that's 13R plus 13R. 13 divided by minus 3, that's minus 39. So we separate from one another again. We are going to have 13R minus 39, that was 0. Minus 39, minus minus, that's plus 39, that's 0 as well. So we are having the factors to be equal to R squared. Where we have this one initially, R minus 3. We are having another factor to be R squared plus 4R plus 13 is equal to 0. Now, we are having these two factors here. According to the question given to us, the R can be gotten from here. I only make sure that we go through this stage in order for us to be able to have idea on about how to be able to use that factor to simplify this, to factorize this expression. We can go ahead to do this factorization here. We cannot make use of factorization method here because when we say 13 times 1, what can we multiply with one another to get 13? That's 13 times 1 because it's an odd number. So we have to make use of either formula method, but we are interested in this value we have here. So you can also say that let R minus 3 equal to 0. Therefore, R will be equal to, taking this 3 here, become plus 3. You know, when minus negative value cross the equal to sign, it becomes plus 3. Now, we have been able to get the value of R now to be equal to plus 3. Now, for us to find the terms of GP now, terms of geometric progression now, will now be equal to, what is the first term? The first term has been known to us to be A, 2, that is 2, that is our first term. The second term, which is AR, will be equal to 2 times 3, that will be 6. And the third term, which is equal to AR squared. R squared will be what now? 3 squared will be 9 times A. 9 times 2 is 18. The fourth term, 3 raised to the power of 3, that's 27. 27 times 2 will give us 54. 54. So we have the terms to be 2, 6, 18, 54, and so on and so forth like that. So that is how you get the value of the geometric progression that we are asked to find. So we have to just express it properly. A is the first term, AR the second term, third term, and the fourth term, like that. Do stay tuned, and please do subscribe to our channel so that you'll be able to have access to all our lectures class.